So what does it take to design a fidget spinner? Let's find out.
There are only a few parts in this design, and it's overall pretty simple. Before you fire up the printer, we'll need to choose a bearing. I went with a large 24mm industrial bearing from MC Master Car. Perhaps a bit overkill, but I really wanted that smooth spinning action for this project. While you're at it, grab an M4 nut and bolt, and that's it for the hardware. Alright, let's dive into the design. So we've got a shell to hold the bearing, there's two shafts that fit inside, enabling the handles to be comfortably affixed without causing any friction, and a bolt to bring it all together. Pretty simple. The bearing is friction fit, which just means I printed a hole that's 0.1 millimeter larger than the bearing's outer diameter. It's very, very small tolerances here. And in essence, we just smash it in place and hope it holds. This is a valid technique, I promise. The shaft uses the captive nut to firmly attach itself to the bearing. By putting a nut on the outside and a bolt on the other side, we can bring these two pieces together, forming a solid joint. Notice that blue lip there? That's designed to only touch the inner ring of the bearing. If it were any bigger, you'd introduce friction to the spinning action. In this way, we can easily mount the large handles comfortably without impacting spin performance. And speaking of handles, they're just friction fit onto the shafts. Since you're generally applying constant pressure, they're not going anywhere. Now if we peek inside the handle, it has a little bit of extra space reserved for any weird jutting features the bolt might produce. This gives us a little bit of leeway should something stick out a bit.
Let's talk about the blade design. You could do something like plan appropriately, draw something on paper, bring it into OpenSCAD, use the polygon tool. I didn't quite have that foresight. I simply just played around with the math until I got this.
Since we're using OpenSCAD, the curvature can be defined with math. A touch of algebra, a hint of list comprehension, some spicy polygon points, and bam, you've got a blade. Just messing with the formula is probably the funnest part of this project. You can create wildly different shapes, even with just basic algebra. Just remember to keep the blade shorter than half your hand, otherwise it won't work. My first attempt resulted in a massive fidget spinner that I couldn't even hold. After a few iterations though, I'm really happy with how it turned out.
Check out the description for the Thingiverse link. It has all of the files used to create this fidget spinner, including the OpenSCAD files, which you can customize as much as you like and create your own designs. Thanks for watching. If you've enjoyed this video, remember to like and subscribe for more content.